All right, today's discussion on the asteroid belt. It's going to be a brief one because we've only got one subject to study today, and that is the asteroids themselves. Where do they come from? Are they the remains of a destroyed planet? How long have they been there? What are they made of? How big are they? Do they match what Hollywood shows me about an asteroid field, or are they something very different? Let's take a look at all those things today. All right. So look at this animation of Ceres. You see Ceres there is spherical, okay? And it has craters and impact zones. It's got fault lines. It's got valleys and mountains. That bright spot in the middle of its main crater there, they think is a field of salt that is just highly reflective. It looks like artificial light, but in fact, it's just a natural feature, a field that is like a field of snow in sunshine, very reflective, but it's actually made of salts. So goes the best science. All right, let's take a look at asteroids and in the asteroid belt, it's theory versus reality. We'll also take a look at what are they made of, what do we know about them, and take a look at some up-close pictures, including the two that were captured into an orbit around Mars and today remain Mars's moons. All right, let's move on with this. Let's get started. So, for size comparison, take a look at the Earth and its moon, and then tiny little Ceres alongside. I put these images together so you could have an accurate representation of how big the asteroids actually are. Ceres itself, the biggest of all the asteroids, is really tiny compared to Earth's moon. In fact, if you were to take all the asteroids and lump them onto the surface of Ceres, and it would be like a supersized Ceres, it would still be only a fraction of the size of the moon. So if a planet was ever going to form there, it would still be tiny in comparison with Earth's moon. All right. I'm going to show you a video clip from a popular Hollywood imagining of an asteroid field. Now, in this case, I want you to focus on the visuals because the sound won't come through, unfortunately. I'm only going to show the bits of it where the Millennium Falcon is dodging asteroids and boulders the size of cities tumbling past each other, crashing into each other, and this is like death every turn you go. The chance of being smashed by an asteroid, it's pretty crazy. Here we go. I'm going to jump over to that and show you a little bit of Hollywood's idea of an asteroid belt. Here we go. So you could see Han Solo diving into an asteroid field. It's pretty intense. And they're like, she's like, "What are you doing?" And he's dodging mountains. So now the bad guys are chasing him, and they don't stand a chance. Booyah! So he finds one that's big enough for them to hide on. And take a look at the rough cratered surface. This actually matches Ceres pretty well. Little cracks and canyons and rough surface, no atmosphere, no vegetation, no life, just a rock in space in the shape of a sphere. And he eventually finds a cave to hide in and dives his spaceship down inside. All right. So there's Hollywood's idea of what an asteroid field looks like. It's filled with danger, and to go through it is pretty much suicide, as 3PO, suggests in that scene. Oh, this is suicide. But what is it really? I made a little image composite on the next slide. Check this out. Yeah, it's pretty empty. Take a look way over there. You can see in the top corner of your screen, that is Ida, the asteroid named Ida. And way down over, yeah, over there on lower is one called Eros. And these two asteroids, I had to put them in this screen so you could see them both, but in reality, they're so far apart they never come within sight of each other. So the asteroid belt in our solar system is a pretty empty place. You could fly your spaceship through it blindfolded and have ridiculously low odds of actually hitting anything. You're going to be safe flying through the asteroid belt. That's the beauty of it. So now we know, based on our studies, yeah, there's a few of them that are big enough and bright enough for us to see with our telescopes, but it's a pretty empty space nonetheless. Let's take a close look at some of those and consider, while we're doing that, was there a planet there? Nah, those rocks are just the leftover remnants of when the solar system formed. That's why the Japanese Space Agency is so keen on bringing back a sample. They're going to get a primal sample of the solar system when it first formed 4.5-ish billion years ago. And then we'll know a little bit about when the solar system, when the Earth, when the sun were just getting started. That'll be a very interesting sample return when they're able to do that. Why didn't it ever form into a planet? There should have been a planet there. It's between Mars and Jupiter. There's a big gap, huge gap in the solar system where there's some, or ought to be something. Problem is Jupiter. Jupiter's the big bully who refused to let those rocks clump together and form a planet of their own mutual gravity. Because every time Jupiter would swing around nearby, the rocks would be pulled on by Jupiter's strong gravity and pulled back apart again, and then it would continue on its merry way, and they would try to clump back together, and Jupiter would come around again and pull them back apart, and they never had a chance to form. But again, even if all the rocks in the entire asteroid belt had clumped together, they would have been ridiculously smaller than even our moon. So a small little planet, if it had ever had the chance. All right, here's what they look like up close. Ida and Dactyl, that's kind of a neat one. Look way over there. Sorry, on the other side. We've got Ida is a pair. It's an asteroid with its own little moon, a tiny little asteroid going around Ida called Dactyl, and they kind of just, there's this little team dancing their way around the sun. Look at Apophis, kind of a kidney bean looking thing. And Apophis has little rock slides on its surface once in a while. They've observed what they think are rocks shifting around, loose rubble on the surface. Top right, Ceres, and its two bright spots, snowy fields, but actually made of salts, just reflecting sunlight brighter than the rest of it. And then Eros, there's the cratered looking potato thing, just a very normal looking asteroid. Okay, so let's consider two very special asteroids now that were actually captured by Mars in an animation of Bennu, and then I'll show you the ones captured by Mars. There it is, high accurate scan, loose rubble surface. This one is just a conglomeration of rocks holding together with barely any real gravity, keeping their shape, and they've got a good map of the surface. Again, lots of rock slides on the surface of Bennu. Okay, now let's go to Mars. Check it out. There's the red planet. Nice, good picture of it in delivered by one of our rovers and probes we've sent out there. And then I've circled Phobos and Deimos in the picture. So you can see where they are. They're actually pretty close to the planet itself. Now, what do they look like? If you were to stand on the surface of Mars and look up, you'll be able to see basically what Curiosity rover did. Pretty good at making selfies. Good job, Curiosity. We like you. And it pointed its camera up and did this pano shot here. But then NASA told the rover, look exactly at that point in the sky because the two moons were passing overhead and one passed right in front of the other. Check out this animation. When I start it up, it's going to be in real time. You'll see the closer one, Phobos, moving in front of the farther one, Deimos, in real time. This is how fast they move if you were to look at them through a camera. Real footage of Mars's moons tracking quickly across the night sky above the red planet. So there you go. Asteroids on tour. All right. So that gets us caught up to page 17, where your first chapter check is now complete. So finish those pages, turn them in to me, show me your work. You can take pictures if you're doing this from home and email them to me, or upload it through Canvas, or physically bring it in if you're in the classroom, and let me just flip through it really quick. I'll assign your grade and you'll be right as rain getting your A in astronomy. If you can get it to me early, meaning Tuesday the 15th, I'll give you extra points, and that raises your grade potentially even higher than 100%. Every semester before, I've always had a handful of students who score so well, their average is above 100% because they're on task every single time. Very impressive work, and they end up walking away with a cool certificate and the high honors trophy. So if that's you, go for it. I would love to have you turn in your work a little early, but certainly don't let yourself fall behind. Let's take a look at the pages up to this point. If you're already caught up with all your pages, you don't need to watch the rest of this video, but let's take a walk through the pages as they have been so far. Page 2, distances. 3 are introduction. Page 4, your list of sources, and 5 is chapter 1, divider page. 6 and 7, sun and the moon. 8 and 9, Mercury. 10 and 11, Venus. 12 and 13, Earth. 14, 15, the red planet. And the one we talked about today, 16 and 17, this profile of the asteroid belt. On the on the left side, your page 16, I would like you to draw at least 3 or 4 of the asteroids. There's a few that I've suggested. If you want to add Mars's captured asteroids and sketch those, be my guest. These are photographs of those places, and you're free to use those or any others that you research online. Look at page 17. It's a little bit different from the fact sheet that goes with the planets. Obviously, planets and asteroids are very different from each other. So just make sure you're following the plan for page 17, and you'll be good to go on that. So there you go. Reach out to me with questions, and we will set any confusion aside and get you ready to go with turning in the first half of chapter 1. Thanks for tuning in. This wraps up our conversation today. Keep looking up.